Hi, and welcome to my first video. We'll be making a Claymation shader in Unreal 5, and this is what Claymation looks like. So we're going to try and replicate those bumps, those animated bumps, and you often get some fingerprints in there too. Okay, so let's get started. I didn't do anything special here, it's just a basic scene, and I made a new material. And so first we're going to make some layers of noise and then transform them into normal maps. So this is the noise factor node where we can choose a few different types of noise. This is the cell noise, but we'll be going for Voronoi, if I pronounce that correct. And so as you can see, this doesn't look like noise, and it's because the RGBA channels have different data. So we can add a component mask, and if I'm correct, the noise we want is in the alpha channel. Yep, but it's very tiny. So let's fix that. It's asking for a well position, so let's give it. And then we can use this and multiply it by some scalar. So we add a scalar parameter and call it scale. Let's see. Yeah, it's a little bit bigger. We'll add a scalar for each uh, layer of noise separately. So for now, 0.5 is okay. Just so we have the possibility to upscale or downscale the whole thing without having to go to the individual noise layers. So the second layer will just do a simplex, and for the third layer, let's see, I think a Perlin, Perlin curl. Let's see how that looks. So here we apparently have a different layer, a different noise in each layer, each channel, the RGB. So these are the individual scalars. And let's call this Voronoi scale. And then we have the simplex scale. And the last one, the Perlin scale. Okay, so we have three layers of noise, which we can scale separately and together. So let's add a smooth step so we can set some range. A smooth step, for people who don't know, is like you can set a minimum and a maximum value, and it will clamp any incoming value between those two. Similar to the color range node in Blender for people who use that. So the minimum, the maximum, and then do that for all three layers. And rename those. And Perlin mix. Okay, so next step would be multiplying them by a strength scalar. So we can also, uh, if we don't like one of the noises, we can tone them down or even zero them out. So the simplex. And borderline. Then next step would be adding them together. And the third layer. And so let's have a look how that looks. Ah, okay, we need to set the values because they're all default 0. Uh, just for now, set them to 1. We can scale them a bit. So the smaller the number, the bigger the noise. Somewhere around 0.01 should do. Let's see what else. Okay, let's set some values here. So we kind of up the contrast if we do this, right? Because we're cutting off lower values. And we can also work with negative values. So let's turn this around. Okay, that looks like something we can use. So then how to turn this into a normal map. We have some, what's it called again? Perturb. Not sure what that means, but it works. So, and this will convert our uh, gray values to normal map. Let's have a look. Maybe we can add a strength multiplier. Normal strength. And we can set it to 10 for now. Hmm. And add a color. You can convert this. Where is it again? Yeah. Hmm. Okay, we forgot to hook up. That's why. Okay, that looks more like it. And we can also use it for displacement. So make a displacement strength multiplier. and hook this up to the uh, well positioned offset. Let's see if it works. Yep. Okay, so that's kind of the basic. Now we we actually want to animate it, right? So yeah, let's save this one, and then uh, we can rename it, and let's rename it to underscore static, and we can copy paste, and let's call this one underscore anim. So how can we animate this? Quite simple actually. We just gonna mess around with the coordinates that go into the noise. So we'll start with a time node, and we're gonna multiply this by its speed. Then we use this uh, to put in the noise. We'll take the cell noise. It's okay. We take actually the cell noise because it's quite how to say, it doesn't have gradients, and so we can clamp this to make sure we always get some value from the noise. And then let's see. I think that's it. We just plug this into the scale instead of the scale. And we should have it animated. Let's see if we create a sphere. And then make a material instance. Call it MI. And assign that to the sphere material. Drag it on. Et voila. So we have animated noise. We can, of course, tweak it a lot, fine tune it with all the parameters all the scalar parameters that we set. Let's have a look. So yeah, change the color, for example, to the typical bluish. And then let's change the speed a bit. It's a bit fast. But so yeah, we can also change all the other ones, right? So you can tweak it to your likings. Well, it's still missing something, and that would be the excuse me, that would be the fingerprints. So where's the master material? Oh, yeah. So let's also get some other noise. We scroll over the UVs and then use a normal map we can blend in. So same principle, time node multiply by speed, but then this time we're going to put it in the yeah, so add the noise, and then we'll use this to influence the texture coordinates. So our UVs, So we add random values to offset it. And then this goes into our we can multiply it by a string or scale, sorry. Okay, and then this goes into our texture sample, which will be a normal map. And we can still add a strength here. And so we use this to lerp between the normals we generated from the noise and the normal map. Okay, so we need a normal map. So I got one from the internet. You can just find any fingerprint normal map. And then we assign this one here. Fingerprint. And we have another error because we do the texture coordinates, which are a flow tool, and we try to add a flow tree. So we need to add a mask before we do that. Or we could change our noise, but I think the cell noise makes it good because it kind of looks like frame per frame change. And let's make sure we have a scale. Yeah, there are the fingerprints. Make that move. Let's see. That's about it. Yeah. So let's have a look at that. Yeah. So there's our results, our Claymation shader with fingerprints. And yeah, enjoy.